In this lesson, I'll show you how to solve equations that are in quadratic form. Let's start with question number 1. Solve the equation x to the power of 4 minus 5 decimal 12 x to the power of 2 plus 4 decimal 08 is equal to 0. This sort of looks like a quadratic equation, except that we have x to the power of 4 as our highest power. What we can do here is rewrite this so that instead of x to the power of 4, we can write down x to the power of 2 raised to the power of 2 minus 5 decimal 12 x to the power of 2 plus 4 decimal 08 is equal to 0. The reason why I'm doing this is so that I can replace x to the power of 2 with another variable, a temporary variable. So I have a is equal to x to the power of 2. Look what happens if I do this. I have a, remember this has become a, so a to the power of 2 minus 5 decimal 12, this has become an a, plus 4 decimal 08 is equal to 0. We now have a quadratic equation which we can solve by the quadratic formula. I won't use the quadratic formula, instead I'll use the function on my calculator, and it can be accessed by clicking mode 5 and then 3. Let's put in our coefficients. The coefficient here is 1, negative 5 decimal 12, and 4 decimal 08. Now mind you, you can do this by hand using the quadratic formula. You'll end up with the same answers. I end up with an a value of 4 decimal 13, and another a value, that's my first a and that's my second, that's equal to 0.9872. 0.987. We'll keep 3 significant figures for both. Remember what we set a as. We set it as x to the power of 2. So I'm going to go ahead and replace this with x to the power of 2, and this one with x to the power of 2. This means that I'm going to have 4 roots, or 4 solutions, because I need to square root both sides. Square rooting this side will give me a plus minus answer for both of these. The square root of 4 decimal 13 is equal to 2 decimal 03. Plus minus 2 decimal 03. Those are 2 solutions right there. And another 2 solutions come from square rooting 0.987. This gives us 0.993, or plus minus 0.993. That's the answer to question number 1. Let's move on to question number 2. This one's a little trickier than question 1. We have our equation 2x to the power of negative 1 over 3 plus x to the power of negative 2 over 3 plus 1 is equal to 0. You need to use some algebraic manipulation to make sense of this. I'm going to rewrite this term so that it looks like this. X to the power of negative 1 over 3 raised to the power of 2. The reason I can do that is because of one of the exponential rules. If you raise a power to a power, you can just multiply them and you end up with this. So if I multiply 2 times negative 1 over 3, I'll end up with negative 2 over 3. There's a reason why I'm writing it like this instead. Because if I continue writing my other terms, I can now replace x to the power of negative 1 over 3 with, once again, a. Let's set a is equal to x to the power of negative 1 over 3. This now becomes 2a plus a to the power of 2. Remember, this has become a plus 1. I'm going to rewrite this so that it's in standard form. A to the power of 2 plus 2a plus 1. Let's see if we can factor this by trial and error. What 2 numbers multiply to 1 and add to 2? I'm thinking 1 and 1. So I can write this as a plus 1 is equal to 0. Now recall we set a equal to x to the power of negative 1 over 3. So I have x to the power of negative 1 over 3 plus 1, and I'm going to set this equal to 0 and solve for x. We have 2 of the same, given that this is a perfect square trinomial, so we'll just do it once. We'll solve for x by taking this 1 over. We have x to the power of negative 1 over 3 is equal to negative 1. Now, to isolate for x, I'll raise both sides to the power of negative 3. Watch what happens. Negative 3 times negative 1 over 3 gives us x, and negative 1 to the power of negative 3, negative 1 to the power of negative 3 is equal to negative 1. So our only solution here is negative 1. That's the answer to question number 2, and that is how to solve equations that are in quadratic form.